Remember, it only needs to be sketched. You don't need to bust out a ruler and all that stuff. No. All right. If you don't have it done, you should have it started at least. What are the two variables? Don't tell me which is which, just tell me the two variables. Variables are things that can change. What are they? Cost and? Number of toppings. Excellent. Which one is independent? Number of toppings. Why? Because the price changes only when I change the number of toppings. Cheese is not a topping. Cheese counts because if you don't have cheese on a pizza, you have bread. No, because bread, we always put some kind of sauce on bread. Butter, peanut butter, honey, Nutella, jam. Doesn't matter. It's still a sauce. Nobody picks up a piece of dry bread and eats it. Here we go. I am in the Ryers. Every chance I get. As a matter of fact, I only eat dry bread. So what goes down here? And over here is cost. What is the fewest amount of toppings I can put on a pizza? 0. And then I can go up in ones. I refuse to write past 4 because more than 4 toppings on a pizza is gross. And those 4 toppings are bacon, ham, pepperoni, and hot peppers. Every other pizza is no good. And if any of you say pineapple, I will fail you. So don't say it out loud. Pineapple has no place on pizza. I am just kidding, Internet. I would not fail my students for bad taste in food.
I like pineapple.
But why did they serve it at the cafeteria?
Huh? Because kids like pineapple on pizza. Grown-ups don't. No, they don't. No, they don't. What's the lowest cost I need on here?
$12.
Mr. Myers, have you seen the pictures on the internet of the guy with strawberries on his pizza? What?
Barf. All right. Where does the first dot go? Eric. You would say 12-0? Wouldn't it be 0-12?
Yes.
Excellent. At 0-12. Is it an open or a closed dot? Closed, because I can input 0 toppings and get an output of 12. Where's the next dot? At 1?
1350 and 1.
1350. Yeah? Where's the next dot?
215.
215. Where's the next dot? 31650. Where's the next dot? 418. Do I connect the line? No, of course not. Why? Can't have half topping. You can put toppings on half the pizza. That's not half a topping. That's toppings on half the pizza. And they charge you for it. You have to make sure when you order pizzas, I want half that pizza to have mushrooms on it. And don't give me any crap where you only put half the amount of mushrooms on half the pizza and charge me for a whole. I want all the mushrooms you would put on the whole pizza but on half, because you're going to charge me for them anyway. Huh? Only if you like, not if you like mushrooms. But if you don't like mushrooms, why would you put any mushrooms on your pizza? Then it would taste like bum.
Maybe the female in your life likes her pizza. You always do what the female wants because it's happy wife, happy.
All right. Is everybody happy with this? Everybody's cool with this graph? Everybody understands why it's discrete? Yes? All right, now, in this blank space here, we are going to do some notes. Those notes are as follows. This is a linear relation. Is it also a linear function? Yes, because for every input I get a new output. All right. How do I know it's a linear relation? If there was a line, it would be straight. Okay? I don't have a line here. So I don't like saying it makes a straight line because then, Kingston, without the line there, one of you is going to tell me on the test that that's not a linear relation because there's no line. So I know what you're saying. You wouldn't draw a line here because it's not continuous. So we have to think of another way to define it that doesn't use the word line because there's no line here. Straight? Okay. That works. But let me ask you this then. Is this a linear relation? Those are all straight lines. What's not even? The intervals. There we go. That's what I needed to hear. Interval's not the right word, but we're going to talk about what we mean here. Soon as my, All right. Here's what makes it a linear relation. Kingston's right. It has to make a straight line. Right? So what this means is any change in what thing is the change that we care about, IV or DV? Right. Any change in the IV results in the same size changes proportionately, and I'll talk about what that means in a second, proportionately in the DV. That's all going to show up in a second. I'm going to show you what I mean in a moment. All right, so this dot right here, if I make a change of 1 in the IV, what change did I make in the DV? 1.5. Did that happen here? 1.5. Did it happen here? Did it happen here? Would it continue to happen? Up until when? Infinity is not infinity toppings for pizza. Eventually, the restaurant runs out of toppings, right? They're not putting Brussels sprouts on your pizza. But no, it wouldn't. You're a liar. Shut up. All right? Is everybody cool with this? So, if it makes this step pattern and they're always the same, then you're going to be in business. What if I told you this? You can only put on toppings in pairs. Would it still make a linear relation? Yes, because I would go out 2 and up how far? 3. So it would still be linear because the IV changes 2, the DV changes 3. Right? What if I told you had to put on triples? Then what would it be? 3 and 4.5. Is everybody good? All right. Now, that shows you a linear relation in words. That's one way we can do a linear relation. Number 2 is a graph. Number 3 is a table of values, which you already know. In grade 9, a table of values looked like this. Right? What does it look like in grade 10? IV, DV, right? And what are our possible inputs for this particular relation? Whoa. 0, 1, 2, and so on. Up to the end of the menu, right? Let's say they're a smart pizza place. They only have like 10 things on the menu. Not like Panago used to have. When I was your guys' age, you could get peaches on your pizza from Panago. You could get smoked oysters on your pizza from Panago. There were many, and Panago wasn't called Panago. It had a different name.
What was it called?
Panagopolis.
Really?
Yes. All right. And the DVs were $12, $13.50, $15, and so on. Yes? Now, on a graph, it's super easy to see. It makes the stairs. On a table of values, it's a little tougher to see. Right? What you got to do is you got to check. You got to check. You got to check. Excellent. +1, right? Then I check here. +150, and it repeats. So it's always going to be the same. Is everybody cool?
How many times should you check it to make sure that's the one?
I was just going to ask you that. Is checking it twice enough? No, because you can always connect 2 points with a straight line. So how many times do you need to check?
3.
At least 3. At least. It's like you're in my head. I like 5, just in case.
I like 3, so that's work.
So the next one would be 3 and 1650. Is everybody good? Okay, now, the thing about graphs, tables of values, and words is they only apply to a small amount of the equation, of the relation, right? Our graph we have there only covers us up to 4 toppings. If this was 1991 and you had the menu for Panago pizza, would you be able to find out how much your pizza cost if you had that menu that had like 300 items on it? No. But this the last method will allow you. And here's how it works. Again, in grade 9, it was XY. We don't care about that anymore because now we're working in IVs and DVs, right? And it went 0, 12, 1, $13.50, 2, $15, 3, $16.50. Now the question I want is how much is it going to cost if I have T toppings, an unknown amount of toppings? Here's how you figure it out. How much every single equation of every single linear function is dependent variable equals the independent variable and some math. Right? You have to do something to the independent variable to get a dependent variable, right? Either add some seconds, add a topping, whatever. Agreed? All right. So here's how it works. First of all, I check. What's the change here? We know it's 1.5, right?
Yeah.
So each time I do this, I'm adding $1.50, right?
Yes.
Math guys are lazy. Do they ever write this? 2 plus 2 plus 2 plus 2 plus 2. No, what do they write? 2 times 5. Right? Everyone agree? So am I going to write 150 plus 150 plus 150 plus 150? No. Would I ever write IV plus 150 plus 150 plus 150? What would I write? IV times 150, right? So right now, my best guess at this equation is the DV, which is cost, equals the IV, right, which is toppings, T, 1.5 times T. Agreed? Everyone cool? What's my value here? 0. So what goes in for toppings? 0. What's 1.5 times 0? 0. But my output needs to be 12. So I need some more math here, don't I? I got to add 12. Now let's check. What's my T here? 1. So what would I write there?
Did you borrow the protractors?
No. I would write 1 there. What's 1.5 times 1? 1.5 plus 12? 1350, are we right? Excellent. What's 1.5 times 2? 3. Plus 12? 15, are we right? Now you have the equation, which will then allow you to tell me how much a pizza will cost, no matter how many toppings I put on it. Let's say it's $19.91 and I want 20 toppings on my pizza. How much will this pizza cost me? $42. Right? Is everybody good? Everybody cool? All right.
How much was the Panago pizza in the 90s?
Huh?
How much was the Panago pizza in the 90s?
Well, you never bought them by one. You always bought them by two.
Oh, so how much was the Panago?
You could get 2 larges for $20. All right. Linear relations now, you should be comfortable with writing them in how many ways? 3? 4. What are they? Words, graphs, what else? Charts, T-chart, table of values, whatever you want to call it. A table and an equation. And they all share IV and DV. It all comes down to that. In grade 9, it was X and Y. Is everybody cool to here?
Yeah.
Yes? Okay, turn the page over. Check this. Which is IV, which is DV? IV, DV, because we always put the IV on the left. Excellent. Great. Is 2 questions. 1, is it linear? 2, you're not going to be able to do it, but we're going to work out the equation here. Okay? So first, is it linear? Let's check. What's that going up by? 5. What's that going up by? 9. Okay? What's that going up by? 5. What's that going up by? 9. Excellent. What's that going up by? 5. What's that going up by? 9. Is it linear? Yes. Now let's work out the equation. Remember, every single equation is dV equals IV and some math, right? Right? If the dV is going up by 9 every time, the IV must multiply by what? 9. Agreed? Okay. So it must be 9. IV is my Celsius, right? So 9C must equal F, correct? So let's check. What's my degree Celsius? 0. What's my degree? So what would I write here? 0. What's 9 times 0? I need my output to be 32. So what would I need to do here? Add 32. Let's check the next one. What's my C? What's 9 times 5? 45. What's 45 plus 32? Not that. So we're in trouble, aren't we? What's different? Why were we able to work it out so easily here and we're having trouble here? The other one's not going up by 1s, is it? It's going up by 5s. If it's going up by 1, it's super easy, right? So what would I do to this 5 to make it be 1? I would divide this change by 5, right? So what would I do to this change? Divide it by 5. And now I've got 9/5 all the way down. So do I multiply by 9 or do I multiply by 9/5? 9/5. Now let's see if it works. 0? Agreed? So what would go in for C? So what's 9/5 times 0? 0. 0 plus 32 is 32. Are we cool? Damn right. Now 5. What's going in for C? What's going in for C? 5. What happens to that 5 and that 5? Cancel. So I've got 9 plus 32. Is that 41? Excellent. What about 10? 9/5 times 10. The 5 cancels, and that 10 becomes a 2, correct? What's 9 times 2? What's 18 plus 32? Fitty, are we right? And now we've made an equation. Does everyone see how it works? Once you get this side to ones, you can always work it out. Everybody with me? Some kids like to see this. Whatever that change is, it has to multiply by the IV. Everybody good? Sweet. Next one. Linear or no? No, definitely not. Why?
Because it goes from 75 to 3.
Goes from 75 to 3,000. No. Next year, you'll learn how to make the equations that go with these. But right now, we only care about linear ones. Let's look at this one. Is this linear? Can you tell by looking at it? Not right now, so we better go to one of our other versions, yes? So we got to either, we've got an equation, we can't tell. So we either have to do a table of values, a graph, or words. Words is stupid, because we don't know what it is, right? They're just X's and Y's, so it's out. Should I graph it, or should I table of values it? Table, okay. Table of values, that's X's and Y's. Which of those is input? X. Who does the input? You do. Does it matter what you choose? No. How many input values should you take?
3.
At least 3, better 5. Now, should I choose 5 random numbers? Why not? Because then it won't show a pattern, will it? When I say give me 5 numbers, the whole class starts going, 73, 81, minus 27, pi! That's dumb. What should it be?
Sequential numbers.
Pardon me? 1, 2, 3, 4, 5 is really good, except you're forgetting half the numbers in the universe.
5, 6, 7, 8,
0.
0 is -1.
Negative 1, negative 2, 0, 1, 2 work really well.
What about would it be -2 then?
Oh, yeah, sorry. I'm a dummy head.
I don't know if I want to be taught by head.
You shouldn't. Fortunately, you're not.
You just called yourself a dummy head.
All right. Now, ladies and gentlemen, please be the class that actually understands this, because every year in the next unit, when I'm about to tell you, for some reason between today and this lesson, lesson 1 in the next unit, everyone forgets what I'm about to say. If negative 2 is x, then what number can I write there? Negative 2. Is that a complicated concept?
No.
And yet, in about a week and a half of you are going to be like, where'd that Q come from? Don't be those kids. Okay? Okay. What then is my y value? It is 2 times what? Negative 2 plus 4, which is what? 0. Excellent. Now, do I have an x and a y?
Yes.
So on the graph, could I put a dot at 2, 0? Yes, and yet that is the next thing that in a week all of you will forget. Don't be those kids. What's next? It's now 2 times negative 1 plus 4, which is 2. So what would the... Negative 1, 2. What would the next one be? 4. Because we're working this out in our heads now, right? You are smart cookies.
Shouldn't be negative 2 on x.
It should be, but it disappeared.
Why does it go 2 to the negative 1? Yeah, why does it go, it should be negative 2, negative 1.
It is negative 2, negative 1.
No, on your red lines. Red, where you're doing the x and the y.
Negative 1, 2.
Go up the next
X.
It's 2.
Oh,
Negative 2.
I think I probably wrote it and it disappeared. What about this one? 4. What would the point be? 0, 4. What about this one? 6. What would the point be?
1/5.
1, 6. What about the last one? 8. So it would be 2, 8. Is it linear? Yes, because when I go up by 1, I go up by 2 every time. Everybody with me? Yes. What about this one? X, Y. -2, -1, 0, 1, 2. What's -2 squared? Times 4? 16. Minus 1? 15. What's -1 squared? 1. Times 4? 4. Minus 1? 3. What's 0 squared? 0 times 4? 0 minus 1? -1. What's 1 squared? Times 4? Minus 1? 3. Hey! What's 2 squared? 4 times 4? 16 minus 1? 15. Hey! What's happening? It's a relation, it's a function, but is it linear? No, because what would it look like on a graph? At -2, I'm way up here at 15. At -1, I'm way over here at 3. At 0, I'm down at -1. And then all of a sudden, it reverses. It's not a V, it's actually a U. It's called a parabola. You're going to learn crap tons about them next year. Now, what do you notice is the difference between the two equations? One's got an exponent. An exponent can't be linear. Why? Because it goes up faster, right? Because it's 2 times 2 times 2, not 2 plus 2 plus 2. Everybody good? Okay, so we've covered now tables of values, equations. Now look at the graph. Is that a linear relation? Yes. Why? When I go that way, 1, I go down 1 and a bit, right? Yes, it's constant. When I go that way, 1, I go up 1 and a bit. That and that are the same amount. So it's linear. What about this one? What about E? No?
If it's 5 by 0 plus 2.
Of course it's linear. Make the graph. When x is 0, oops, x, y. When x is 0, what's y? 2. When x is 1, what's y? 2. When x is 3, what's y? 2. Plus 1 plus 1 plus 0 plus 0. It's the same. So it's linear. F. No. G. It is a parabola. G. Parabole, parabola, parabole, parabola. Anyone? None of you ladies were in Girl Guides? None of you saw Sound of Music? Val-de-ree, Val-de-ra. Nothing? You're liars. Some of you have seen Sound of Music. It's on every Christmas. Whatever. Linear or not? Yes. Make a table of values and graph. We already know, but we're going to graph it. What do I need? What do I need? I need some x values. Who chooses them? You do. Does it matter what you choose? No, but should you choose x equals -80? No, why? My graph doesn't go to -80. -2, -1, 0, 1, 2.
This is the same as question
Yes, it is the same. What are they?
0, 2, 4, 6, 8.
0, 2, 4, 6, 8. Graph it. -2, 0. 0, 1, 2, 3, 4. 2, and it makes a nice straight line. Yeah?
That one's going straight up and down.
Everybody good?
Yes!
Okay, what about the other one?
No.
-2, -1, 0, 1, 3. What's -2 squared?
4.
What's 4 minus 3?
1.
1. What's -1 squared?
1.
Minus 3.
-2.
-2. What's 0 squared?
0.
Minus 3.
-3.
What's 1 squared?
1.
1. Minus 3.
-2.
-2. What's 2 squared?
4.
Minus 3.
1.
Graph it. -2, 1. 0, -1, -2. 0, -3. And then it just reverses. And it makes this nice fancy U. Parabola, parabole, parabola, parabole, parabola, ha 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 ha. No, it's a song from Sound of Music. No. You guys already don't do your homework when I give you all night to do it. I have to give you extra time in class for you to waste and not do it. And then complain that you don't know how to do your math.
I don't do my math, I just don't want to do my math. Thanks, Mr. Ryan.
Okay. Listen, please. The homework for tonight looks long. But when you look at the page, you can see that one question takes up like a quarter of the page because there's graphs and tables and things. So it's actually not a lot of work. As always, do some of it. Now, if you have to make a graph, you can do one of two things. You can sketch it, or you can actually go get some graph paper and use graph paper. It doesn't matter to me, right? I just sketched them when I was your age. I didn't bother getting graph paper. But some of you will need graph paper. You're welcome to get it. All right? The work tonight is encompassed on page 160 and 160 up to 162. And then the answers start. It's actually not a lot of work. It just looks like a lot. Some of the photocopying is pretty crappy. If you can't read the photocopying, don't do the question. Or ask.
I can't read any of this.
Is everybody good? Okay? Go. And you've got 28 minutes.
I gotta go pee.